This video is notes over 6C. Target 6C is identifying patterns of associations in data using two-way frequency tables. So you need to be able to create a relative frequency table, that's this right here, the relative frequency table from the two-way table, create a segmented bar graph, and then use those things to determine if there is an association. So a scientist wants to know if the color of water affects how much animals drink. The average amount of water each animal drinks was recorded in milliliters for a week and then graphed. Complete the two-way table. So I'm going to complete that two-way table using subtraction. So I can see that I know the total amount of blue water that was drank and I know how much the cat drank. So to find this missing part here, I would take 1,410 minus 210. And that gives me 1,200. Then here, I'm gonna go down for our dog intake. So I know that the dogs drank 1,200 of the blue water, 1,100 of the green water. So I'm gonna take that 1,200 and add 1,100, which means the dogs drank a total of 2,300. Then I can figure out the total cat water here because I know the total altogether. I know how much the dog drank, so I can use subtraction to find how much the cat, which would be the 2,710 minus 2,300. Clear this. 2,710 minus 2,300, and that would be 410. So if there's 410 and 210 of it is blue water, that would mean the green water would have to be 200. And then going straight across, I know that the cat drank 200, the dog drank 1,100. I can do that. That would be 1,300. Okay, so now my two-way table is completed. Leave my calculator here, I still need it. I now need to complete the relative frequency table. We missed that word there, but that's okay. To calculate the relative frequency table, I need to look at of the blue water drank, so this is the total. We're looking at the amount of blue water. What percent did the cat drink and what percent did the dog drink? So I'm looking here, the blue water is my 100%. I'm going straight across. So I know the total amount of blue water that was drank was 1,410. I'm gonna put that above here, just so I know that that's what I'm using as my 100%. The green water, the 100% in the green water was the 1,300. So now I'm going to look at, of the blue water, how much did the cat drink? So the cat drank 210 of the 1,400. So we do 210 out of the 1,410. We divide those. All right, so I get 0.1489 and some other numbers. I'm gonna multiply it by 100 to make it into a percentage. So I have 14.8. I would round this up to be 15%. Then I've got blue water. I need to do the dog. So this would be 1,200 out of the 1,400. I am not gonna actually write this in because I'm realizing how squished with space we are here. So I've got the 1,200 was the dog's blue water out of the 1,400, 200. So 1,200 out of 1,410 times 100, which is 85.1, which I can round to be 85%. Next, I'm gonna do the green water. So I have cats drank 200 of that 1,300. So 200 divided by 1,300, and then multiply it by 100. We've got 15.38. I'm gonna round that down to be 15%. And then 1,100 divided by our total for green water, which is 1,300 times 100, so 84.6. That would round up to make this 85%. All right, so now I'm gonna go over here to create my segmented bar graph. So before I even do any segmenting, I know that the color of the water is already represented down here with these labels. So what my shading needs to be is the cat versus the dog. So I'm going to shade in, I'm gonna use this. I'm gonna shade in the dog, and I'm gonna leave the cat blank. So whatever the cat drank is gonna be blank. All right, so no matter what, whenever we are doing our segmented bar graph, they always go up to 100% because we are looking at the total of the blue water, or the total of whatever we are matching or measuring here. In the blue water, the dog drank 85%. So 75, 85 would be just above that. So I'm gonna write 85% because that was one of the ones that was an estimate. And so this leftover piece would be the 15% for the cat. And I already labeled down here that the shaded in part or section is the dog. So I'm gonna shade that in because the dog was 85%. Then for the green water, the dog was also 85%. So I'm gonna do my absolute best to make those go up to the same amount. The reason we label is because you might not be totally perfect, and that's okay. I think mine is a little too high. And again, 85% is the dog. So I'm going to shade that in. All right, so I have got my relative frequency table. I have my segmented bar graph. Now I need to check for an association. So is there evidence to suggest an association between watercolor and animal? And I would say yes. Actually, I'm sorry. No, there is not, because the same amount of, or same percentage, they are the same for each color water. So this is no, they are the same percentage for each color water, so it doesn't seem like there is a difference based on the color of water. So the percentages are the same. For dogs and cats, for green and blue water. So I can put in parentheses, there is no difference here. I don't see any difference. Maybe if this had been flip-flopped and I saw like a lot more dogs liked the blue water, but I can see that the dogs are the same for blue and green water, and the cats are the same for blue and green water. There's no difference for those animals between the two types of water. So no, there is no association. This is the type of answer we are looking for when you get to a question that says, is there evidence to suggest an association? Remember that this is one of the learning target, or in this learning target is one of your success criteria. You have to be able to do this part where you describe what's happening. So at this point, you are completing the rest of this page as your practice. So there is a front and a back. This should be filled out on your paper because you just watched the video with me, and then you are completing the rest of the front page and the back. That is your task for today.